Finally, acceleration is the rate at which velocity changes, and acceleration also is a vector. It's your change in velocity divided by time, so that could also be written as v minus v naught over t. It's a vector, and its units are meters per second, or meters per second squared. That sounds a little funky, meters per second squared, but it really is saying if you have an acceleration of 5 meters per second squared, that's 5 meters per second. It means your velocity is changing 5 meters per second every second. Let's look at one last problem. If Monty the monkey accelerates, it's a smiley monkey, Monty the monkey accelerates from rest to a velocity of 9 meters per second in a time span of 3 seconds. Calculate Monty's acceleration. Well, acceleration is delta v over t. Delta anything is its final value minus its initial value divided by the time. The final velocity was 9 meters per second. The initial velocity, it said he was at rest, so that's 0, in a time of 3 seconds. 9 minus 0 is 9. 9 divided by 3 is 3. That will leave us with an acceleration of 3 meters per second, or 3 meters per second squared. And acceleration is a vector, so technically we do need a direction with this. However, it's fairly obvious from the problem that we're talking about the forward direction. So in this case, it's probably okay to not write the direction down. But really, if we wanted to be technically correct, we should have a direction with this as well. So next steps, take a few minutes, try and sort these concepts out, and see if you can explain in your own words the difference between position and distance, between distance and displacement, between speed and velocity, and finally between velocity and acceleration. If you can explain the way that you understand it, the difference between those terms, you'll be in pretty good shape. Of course, if you need more information or have questions, check out aplusphysics.com.